Bismillah ar-Rahman ar-Rahim. Today we'll start chapter 10, solid waste management. An overview of the solid waste management. The meaning of solid waste mean paper and plastic generated at home. Of course, one of the other processes that might be called waste management, ash produced by industry. When you burn medical waste, you get ash at the bottom. If you have like a fireplace, and if you dump the medical waste, all these injections, all this expired medicine, okay, when you burn it, air pollution will come out, and of course you have to have a control to clean up all these dioxin and very toxic air pollutant. But at the bottom of the furnace, you will have ash. So the ash produced by the industry is also called a solid waste management problem. Cafeteria food waste is also another solid waste problem. Leaves and cut grass from parks, hospital medical waste, demolition debris from a construction site. When we see the generation, storage, collection, transport, and processing and disposal of solid waste, you can see that the generation of the solid waste comes from residential waste, commercial waste, construction and demolition waste, institutional waste, municipal services waste. Of course, all of these waste coming up from each different generation areas will be stored. It will be gone to a storage, and then they will be collected. Okay, and then after collections, either it goes to a transfer station, then sent back to a landfill, or after collection it might go to incineration, and some of the ash will go to landfill, and some of it, the air and the heat, will go as an energy recovery units. Some of the collection will go to material recovery facilities, and then whatever they recycled and recover, it will go to as a recycled material, and the rest that cannot be recycled will go to the landfill. Some of the collection solid waste will be going to composting, and then you'll start either composting or the rest will go to landfill. So this is an idea of what will be happening to solid waste from generation to processing and disposal. Landfill also, some landfills you'll have some energy recovery units to produce electricity and energy generation. When you study solid waste, you have to understand what is the characteristics of this solid waste. Solid waste is characterized by the following: by the source. Remember, we have all these sources: residential, commercial, construction, demolition waste, institutional, and municipal services waste. So either the source, the original use, is it glass, plastic, is it hazard or not hazard, what is the underlying physical or chemical composition. So the characteristics is based on the following 4 items. Sources, as we just mentioned before, residential is one of the sources of solid waste, like detached homes, apartment. Of course, things that might come out of residential is food waste, yard and garden waste, paper, plastic, glass, metal, household hazardous waste, and typical percentage of municipal waste is 30 to 50%. Commercial: stores, restaurants, office buildings, motels, auto repair shops, small businesses. It's the same as the above. Of course, you'll have food waste, you'll have yard and garden waste, paper and plastic. Also, this is more variable from source to source. And of course, you'll have some small quantity of specific hazardous waste. 30 to 50% typical percentages of municipal solid waste. Institutional, which means that schools, hospitals, prisons, military base, nursing homes. Same as the above. Okay, it's of course variable of composition between source to source, and this is from 2 to 5% typical generation. of percentage of municipal waste. Construction and demolition waste, building construction or demolition sites, road construction sites, of course also road demolition sites. Concrete, metal, wood, asphalt, wallboard, and dirt, bitumenite, some hazardous waste possible. All this might come from construction and demolition solid waste. This is 5 to 20%. Municipal services, cleaning of streets, parks, beaches, water and wastewater treatment, grit, biosolids, leaf collection, disposal of abandoned cars and dead animals. This waste might vary among municipalities. From each municipality, it might have some highly variable waste. And this might go from 1 to 10% percentage of municipal solid waste. Industrial, for example, light and heavy manufacturing, large food processing plants, power plants, and chemical plants. This can produce large quantity of homogeneous waste. It can include ashes, sand, paper mill sludge, fruit pits, and tank sludge. Okay, and that is not included as a municipal solid waste. It will be included as hazardous solid waste, and we'll be talking about this in the next few slides. Agricultural, cropping farms, dairies, feedlots, orchards, spoiled food wastes, manures, unused plant matter, straw, hazardous chemical, and this is not called, it will not be called a municipal solid waste. Okay, so the last one, mining, which is like coal mining, uranium mining, metal mining, oil and gas exploration, and also this can be produced at vast amount of solid waste, needed specialized, very important specialized management. That's also not considered a municipal solid waste. Okay, quantities of municipal solid waste in the United States over time. Let's look at through time the million gram per person per year. Okay, how many million grams of solid waste per person, per people, per year? Let's look at 1960. It was 0.44. 0.44, the unit is like this, 0.44 million gram per person per year. 1970, it increased 0.54. 80s increased to 0.61, 1990s 0.76, 2000 0.78, and you can see that the EPA is working so hard to reduce this. So in 2010 you can see some good reduction, 0.74. How much is recycling? How much million gram per person per year being recycled in 1960s? 0.03, 0.04 in 1970, 0.06 in 1980, 0.11 in 1990, 0.17 in 2000, 0.19. That's huge. So you can see that there is an increase in recycling over time. 0.19 million gram per person per year is a huge amount of recycling. Composting, it was not a big matter in 60s, negligible in 70s, negligible in 80s. Now they start doing this in 1990, 0.01 million grams. 0.05 and 0.06, and this is increasing with time. Incineration, the same thing, 0.01 in the 1980s, 0.11 in 1990, 0.11 in 2000, and 0.09 because of the possible air pollution and air contamination that might come to it. Landfills, 0.42, 0.52, 0.54, 0.53, 0.45 reduced because right now it's good that they are transferring stuff to recycling and composting. And 0.4, and you don't want to landfill everything, you want to collect it, recycle it, compost it, and then send the remaining to landfills. You can see here that the 2010 generation rate is 0.74 million gram per person per year. This one excludes construction and demolition debris and biosolids from wastewater treatment plant. And recycling the waste has increased from 6 to 25%. Okay, so this is the recycling increased from 6% to 25%. That's a huge increase. You can see a typical solid waste will have the most of the items that might come inside is paper and cardboard, 28.5%. The next one is yard trimming, 13.4. Food scraps, 13.9. Plastic, 12.4%. And the next one is metals, 9%. Glass, textile, 5.3. Wood, 6.4. Glass, 4.6%. And rubber and leather is 3.1%. And the others, 3.5. So this is a typical explanation of what is the content of the solid waste in any typical solid waste program. Let's look at solid waste composition for 5 cities of the world. Let's look at India, a city in Philippines, Manila, Paraguay, Mexico, and Colombia. Let's look at the food waste. Okay? 75.2. Okay, this is in million gram per person per year. So this is 0.146 for India. You can see the generation of solid waste is 0.146. Which one of these cities will have highest generation of solid waste? You'll find here that Bogota, Colombia City has 0.27. The next is Mexico, 0.248. And then Paraguay, 0.168. And India and Philippines has the same generation of solid waste. Seems to be here they decompose and they recycle more. Let's look at the properties. 75% of the solid waste in India is food, while 60% in Paraguay is food. You can see here 45 in Philippines, 59.8 in Mexico, and 55.4 in Colombia. Let's look at the paper waste. The highest paper waste is in Colombia. Next is Philippines. Of course, 1.5 is India. India is generating less paper waste. Let's look at the metals. 4.9 Philippines, and India is generating the lowest metals. India is generating a lot of food waste. Glass, Paraguay and Colombia are generating a lot of glass, 4.6% each, while India is generating less glass waste. Plastic, rubber, and leather, you can see that Colombia is producing a lot of plastic, rubber, and leather. Textile, you can see that also Colombia is producing high. India here, they're producing high waste of textile. Now, ceramic, dust, ash stones, Philippines is producing more. And the generation we just talk about it. This is a very good example of a table. You have to understand the meaning of each one of them. Let's look at this example. Solid waste composition and the quantity of solid waste generation from 2 cities located in the developing world as follows. City 1, 47%, 65.5 for City 2. Paper and cardboard, 6.3%, 6.5%. Ashes, 36, 10.2. Others, 10.7, 17.8. Waste generation, this time in kilogram, not in million gram like the other one, 0.38 kilogram per person per day and 0.28 kilogram per person per day. Which city generate more ash on a per capita basis? Which city generate more non-ash waste on a per capita basis? Let's look at this. Let's look at City 1. City 1, they have the generation rate 0.38 kilogram per person per day. City 2, remember, 0.28 kilogram per person per day. What's the percentage of ash in the first city? Remember, the ash is 36%, 10.2%. 36% over 100 and 10.2 over 100. This would give you city 1, 0.14 kilogram ash waste per person per day, while city 2, 0.03 kilogram ash waste per person per day. Which one produce more ash? Of course, city 1 will produce 0.14 kilogram ash waste per person per day. Okay, now we want to find out the non-ash. We'll do the same thing. We have ash, the non-ash is 1 minus the percentage. So we'll put the same thing, the generation of city 1, generation of city 2. So this is 36%. So we're going to do 100 minus 36 over 100. This is 0.24 kilogram non-ash waste per person per day. While city number 2 is 100 minus 10.2 over 100, 0.25 kilogram non-ash waste per person per day. You can see from here that city 2 will produce higher non-ash waste other than city 1. In this example, it is very important to do a waste characterization, which is an important aspect of solid waste management program. Because waste generation and composition can differ within country and can also differ between city to a city, and can also differ between India and Philippines, like the one we just gave you. Physical and chemical characterization of waste. Solid waste characterized by also waste density, moisture content, energy content of the waste. Of course, because selection of a particular management option for solid waste depend on the specific physical and chemical characteristics. So these characteristics will depend on what type of management we're gonna apply for the solid waste. Physical and chemical characteristics of solid waste. We need data on waste generation from municipality in terms of mass units, like mass per person, per capita, per time. Not volume units, grams, kilograms, million grams, pounds, okay? Because there is a volume and variations in density. So we don't use volumes, we use mass per capita per time. Because the increase in density due to the compaction of the waste in a truck or in a landfill and from baling materials are also important in economical analysis of solid waste management system. So this is the last slide. I'll try to go through this quickly and then we'll do the next video later on. Common physical and chemical characterization of solid waste components. Let's look, if the mixed municipal solid waste, if it was loose, remember, if every truck there is a compactor to compact the solid waste. If it was loose, the density range goes from 90 to 180 kilogram per meter cube. If it was loose in a developing country, it goes from 250 to 600. Compactor truck, it goes from 300 to 420. After dumping from compactor trucks to 10 to 240. In a landfill, it goes from 480 to 770. That's initial. And then with overburden, goes from 700 to 1,100. Shredded, 120 to 240, and baled for 80 to 710. Recovered material, if it was loose, bordered reviews, you can see the density range, aluminum scrap, ferrous scrap, cardboard, aluminum cans, plastic containers, and newspapers. And you can see that this density analysis is very important to understand how to manage the solid waste problem. You can see also the recovered materials. If it's baled aluminum cans, this is density, cubed ferrous cans, and baled cardboard, baled newspaper. So all of this is important to understand what type of analysis, of management analysis for this type of solid waste. Okay, and we'll start this point after this lecture. Thank you.